My today's topic is Nernst equation. Nernst equation. This equation gives a relationship between electrode potential. So it gives a relationship between electrode potential of an electrode and concentration of electrolytic solution, or the activity of the electrolytic solution in which the electrode is dipped. So this is the equation. It gives the relation. The equation is E is equal to E naught minus 2.303 R T divided by NF log of Q. I will explain every term. E is the electrode potential. E naught is also the electrode potential, but under standard conditions. What are these standard conditions? Standard conditions are: the temperature should be 298 Kelvin, 25 degrees Celsius. The pressure should be 1 bar, and the concentration or the activity should be 1 molar. That is 1 mole per liter. And then we have R. R is the gas constant. We have different values. One of them is 8.314 joule per Kelvin per mole. And then we have T. T is temperature, but on absolute scale, absolute temperature, Kelvin scale पे. And we have N. N is the number of electrons, or the number of moles of electrons transferred during the reaction. Then F is the Faraday's constant. And it is actually equal to the charge on 1 mole of electrons, which is 96500 coulomb approximately. And then we have the Q. Q is the reaction quotient. And what is this reaction quotient? Reaction quotient is nothing but the ratio of concentration of products and reactants. So suppose we have reaction like this: A plus B giving 2 times C plus 3 times T. Suppose in this case the Q is the reaction quotient is the concentration of C, the products, to the power 2 into concentration of D to the power 3 divided by concentration of A into concentration of B. So this is the reaction quotient. In case of reversible reaction, we call it equilibrium constant K. Okay, so this is the Nernst equation. It can be applied to determine the electrode potential at various concentrations. You can see the concentration is here, products and reactants, and temperature dependence is also there. The number of electrons, the number of moles of electrons which are involved, that will also influence this. So everything is covered in this equation. But now the question is, where from we get this equation, the derivation of this equation. Derivation of Nernst equation. So where from we will get this equation? Let me tell you how to do it, but take a pause. In the next video I will let you know how to derive the Nernst equation.